So the William W. Hay Railroad Seminar Series is sponsored by the Rail Transportation and Engineering Center here at the University of Illinois at Urbana-Champaign. And on behalf of all of us, we thank AAR, the NSF, Hanson Professional Services, and the National University Rail Center of Excellence for their ongoing support of RailTech. It is greatly appreciated by those of us here on campus, as well as those participating via the internet. Our list of attendees today includes freight and passenger railroads, transit organizations, federal and state DOTs, engineering firms, universities, research organizations, technology developers and suppliers, and others. We are very pleased that you can join us today. If you'd like to receive PDHs for your participation, please see the instructions at the web that were on the announcement, and you'll send an email to heyseminar@illinois.edu. And if you need assistance with this, Emma can certainly help you. So CN, as I think most of you know, is one of 6 major North American railroads. Its network is about 20,000 miles in length. I guess actually it's longer now that we have the Iowa Northern in the family. And it was the first railroad to connect the Atlantic Ocean, the Pacific Ocean, and the Gulf of Mexico. As such, it extends from the subtropical environment of Louisiana to the subarctic regions of central Canada. In reaching the Canadian West Coast, it traverses 1,000 miles of windswept prairies and then crosses the Canadian Rockies, a major mountain range, of course. So operating a railroad with such a wide range of environmental conditions means that it is exposed to a wide variety of operational, maintenance, weather, and public interface situations. All of these require successful response and resolution on a daily and indeed an hourly basis in some cases. The engineering team that must respond to these challenges must have diverse talents and 24/7, 365 commitment to solving a wide range of problems that can arise. Although some might find such challenges daunting, others are energized by them, and that's the team we're going to be talking about today. Our speaker leads that team, and she's going to discuss what it's like to be part of an organization that is dedicated to keeping the railroad running day in and day out under this wide range of conditions and challenges. Paula Pienton is a chief engineer, bridges and structures at CN Railroad. She completed her BS in civil engineering here at the University of Illinois and has more than 40 years of professional engineering experience in the transportation experience. She's responsible for CN's entire network of bridges, structures, and geotechnical engineering, design and construction team, public works, including operational safety, management, and maintenance. She and her staff have responsibility for design, repair, and reconstruction of CN's bridges and structures, as well as the associated policies, procedures, standards, and budgets related to these assets. This is no small responsibility. CN currently maintains about 7,400 bridges, 110 tunnels, and 53,000 culverts. And this does not include the assets of the recently acquired Iowa Northern Railroad. So she just added to her portfolio. Her team also has responsibility for construction of new capital projects to increase capacity and expand CN's business reach. Also third-party agreements, maintenance agreements, coordination with public agencies, and emergency response related to these facilities. Prior to joining CN, Ms. Pienton worked for several engineering consulting firms on transportation projects throughout the U.S., including freight, transit, and highways. Please join me in welcoming Ms. Paula Pienton, who will present today's Hay Seminar, A Day in the Life Working on the Rail.
All right. Is my voice coming through? It is. Okay. Get this here. So thank you for joining me today. I apologize. I was supposed to be here 3 weeks ago. I was redirected. I will talk about that a little later. But I'm here today and I'm happy to be here. So I thought I'd start us with a safety moment. Safety is a core value at CN and probably all of the railroads, but we do live it. I was going to talk a little bit about the departments and how we're organized. Try to give some of the students a vision of where they might fit into an organization like ours. Talk about my team and then just give you a little snapshot. It's more about a couple weeks in a life of just to show you the diversity of things that comes up on a regular basis for us. So a little bit about my personal vision is that my team understands what they're going out to do, what their task is for the day, that they each individually know how they're contributing to that task, that they've looked at the site, identified the risks and exposures and mitigated what they could. I want the job site to be organized and orderly. I don't want messy because that helps people make mistakes. And I want everyone on that site, whether they belong to my team, a contractor, a consultant, a regulatory agency, I want them to feel empowered to stop work if they see something that's not right, if things aren't going the way it was expected, or maybe they're not sure what they're supposed to be doing in that moment, or somebody on the team isn't doing things in a safe manner. And what that's going to do is allow that team to go home the way they came in that day, and we will have achieved our goal of whatever the task may have been. The absence of an injury does not mean that it was safe. It just means we got lucky. So we're always working to identify those risks and exposures and try to work as safely as we can. Where I see our biggest mistakes is when we get very comfortable in what we're doing, we become lax, relaxed, and we're not paying attention. And that's when accidents occur. So we start every day with a job safety briefing, and we usually ask somebody on the team to give their personal vision. So it's something we do, something we live. So a little bit about CN and where we lie. So my boss, the Vice President of Engineering, Jamie Lockwood, reports into the COO of Network Operations. CN has 2 COOs. It's a little different than some of the other railroads. But we are on the operations side of the house, putting us in the same school as the mechanical team, the RTC centers, which control traffic on the railroad, our safety and environmental teams, and then our efficiency and things like that. So I report up to Jamie, and then my peers cover the signal and communications team, the track. We have capital efficiency and capital planning, and then safety. We have our own lead safety person for engineering. So engineering in general is responsible for the care and keeping of infrastructure across the network to allow the safe passage of trains. The team is about 25% of CN's employees. We're about 6,000 strong. And we've got 25,000 miles plus of track, 900,000 pieces of signal equipment out there that need to be touched quite frequently. We have a fleet of work equipment. We have a fleet of company vehicles outside of work equipment, and we have a strong inventory of materials on hand. This year, our budget is well in excess of $3 billion. Of that, my team is probably responsible for about 800 million to invest in this capital year. For me, I have 7,400 bridges, 53,000 culverts, over 100 tunnels, countless retaining walls. We have a lot out there that we're responsible for. So to help me do that safely, we have a team. We have a headquarters side of the house, and we have a field side of the house. I have about 600 employees, 170 or so are management. The rest are union forces. Reporting directly to me, I have 2 assistant chiefs, one for bridges and structures and one for design and construction and public works. I also have the geotechnical team that reports in directly to me. And I have a construction specialty person who is our troubleshooter for emergency responses. And then I have regional operations. I have 3 senior managers in the regional team. Just to give you a sense of what that is, we have the Eastern region of Canada, the Western region of Canada, and then the United States. And I will tell you, when I got to CN 4 years ago, it was like 3 individual railroads. And they were at one time. That's how we acquired services, but we had different practices and we did things differently, even though it was the same task. And so what we've been working toward is best practices across the network on the bridge side. So it's been a journey, but we're making progress and people are buying in. So my regional senior managers and bridges, they are responsible for the maintenance and construction of bridges, tunnels, culverts within their territories. So they are directing the daily operations of the union forces, making sure invoices are paid, lining up contractors where we need the support, arranging for work equipment to be on site. My public works team works more at a network level. They are not so specific to a region. And then geotechnical is also, my senior manager of geotech is responsible for the whole network. A lot of responsibility and a lot of different geographies that he has to work in. So my system bridges, we don't always talk about the number of bridges. It's very hard to get a number of bridges. We talk about span and how many miles of bridges we have. So, and then we break it out into concrete, steel, and timber. And as you might see here, I have a lot of steel bridges that are over 100 years old. They have reached their end of life expectancy, and we nurse these along to keep them in service and reliable. So it is an aging infrastructure. It is not a new asset. So we have our challenges, and budgets, especially in the world of tariffs, are slipping away. On the headquarters side of the house, we have in-house design services. We design as many of our own bridges as we can possibly push through on our own. We have a efficiency team, or not efficiency team, our quality management team, which is responsible for inspection and rating and regulatory filings for our bridges. We have our assessment team, which we do all our own in-house ratings of our bridges for load capacities. And then we have some special project managers for some of our bigger deliverable projects on Facebook. So bridges and structures, you know, the inspection team, we have our in-house equipment. We do all of our own inspections. Our assessment team, they are responsible for giving a load rating for the bridges. They're responsible for approving any heavy loads or wide loads or dimensional loads out there, anything different. When we have industries come to us, British Columbia, northern British Columbia is exploding with mining opportunities right now. We have rail lines up there, the subdivisions that don't see a lot of traffic, they don't get our biggest investment. So these new companies, they want to run heavy, often long. Well, that comes at a cost. So this is the team that says what has to happen to those bridges in order to accommodate the new loads. My design team does just that. We do plans, replacements, permitting, anything we need in order for the team to go out and build the bridge. And then construction and maintenance, that's my union forces. We do build our own bridges in-house. So that's what we do. The design and construction side of the house is responsible for all capacity work where we want to add track, where we have bottlenecks on the system. We may be adding double track, we may be adding sidings. Any industry leads, we work with the business development team as they're out there selling new services and we have to put a new lead into a new industry. This team is responsible for reviewing and approving that construction. We have an estimator with that team. We got in a little trouble some years back before actually I had this team with back of the envelope type estimates. So we've gotten a little tighter with how we deliver numbers to the corporation. And we recently added a track designer to this team as well. And then on the public works side, that is for all rights of entry, for utilities, for any work that has to happen. If you're building over us or under us, it's also all our grade crossings. They are responsible for the care and keeping of all of that and making sure we are meeting regulatory requirements. So wanted to give you a sense of some of the work we do with our own forces. We do a lot of substructure repair and restoration of concrete. We build our own bridges. We replace a lot of bridges with our own. We have standard precast sections that are our typical bridge. And so pretty easy. We drive our own piles, we set our own spans, and we do it all ourselves. We do a lot of timber maintenance and repair. I have over 31 miles of timber bridges on the system out there all around. So those take a lot of nurturing. I have some steel gangs that I would put up against anyone. You can see here the Joliet 76.3. We are strengthening these tower vents on a bridge, and we're doing that all in-house forces. They're amazing. They work in extreme conditions. And then we're responsible for building all culverts on the system. So anytime there's a washout or anytime we lose something, it's our team that goes out to get back together. Now here's something I had never thought about: avalanche control. We are proactive in managing avalanches out in the Rockies. We've lost trains to snow pack coming down. So we monitor, we go out, we detonate. You can see in the color picture, there's a detonation happening up there. We bring it down. We have identified the alleys that are likely to have movement on them. We monitor the snowfall, we monitor the stability. We have helicopters go out, drop the detonations. We try to bring that down in a safe manner so that we don't lose a train. We are committed to making sure that our trainmen are safe when they are bringing their trains through. They travel through some crazy conditions. So, but this is something I didn't even know existed, quite honestly.
Central Illinois.
Yes, I am from Central. I am flatlands. I like flat and straight. It's good. So our geotechnical team is responsible for stabilization work. Out in the Rockies, we've cut a railroad into the side of a mountain for over 220 miles. It's not always stable. We get a lot of rock coming down. We've got to try to proactively manage that. Sometimes we get boulders that come down, boulders the size of school buses, and they take a train down with them. So just last spring, we had a train in the river from a boulder coming down. So then this picture here shows these guys scaling the mountain. They go out there and they drop rock. They evaluate the stability of the boulders on the side of the mountain. We put damage mats over the track, so we're controlling damage, and we bring those boulders down. Not a job I would ever want to do. We have landslides and land subsidence. You can see here, we've got it marked out. That particular instance, we had built retaining walls. We had tried to retain the track. Below there, what we've done now is move the track over about 60 feet. We had to buy land. We had to get indigenous properties, agreements with the indigenous population to do that. But we can't stabilize a massive land movement. So we just have to get off of it and into stable ground. Sometimes that's the only way we can recover, is to rebuild. So that team has their hands full. They do a lot. My bridge inspectors, they're qualified to do rope inspections. We have our own snooper vehicles. They can do it all. We do bring in outside resources when we're tied up and we can't get to everything. But each of those bridges has to be touched once a year, and some of them more frequently if we identified issues. We also use outside resources for our underwater inspections. Bridge testing. I think we may be the last railroad that still has this in-house. We have a team that will go out and put strain gauges on, get readings. They work closely with our bridge assessment team so that if we're getting close on a load rating, we'll go out and do some testing to see, can we up this? Do we have more resistance here than we're safely assuming we have? And so that's a nice companion team. So we do like to have that in-house. It's available when we need it. We had a bridge that failed last August. It was a movable bridge. We had a hydraulic failure and it closed unexpectedly, and we did heat straightening on a good portion of the web and put it back in service. But we didn't do that until we had strain gauges in place, and we monitor it weekly to make sure that we haven't over simplified our solution. So it's really nice to have that in-house and at our beck and call. And then we have earthquake response. We are the only railroad that uses ground acceleration in our criteria for our response on an earthquake. It's not popular with the rest of my executives because it's a little more conservative than just going by the seismic reading. But we do think it is the right criteria to use. The frequency of earthquakes in Western Canada is growing exponentially. We have suspended service, I think, about 15 times so far in 2025. There's a lot of fracking earthquakes in Alberta. We're looking at trying to reevaluate our criteria for that because we haven't found damage with that. But in the Vancouver area recently, we've had a lot of activity, and that is my busiest corridor. Stopping trains until I get eyes on all the bridges is really not a popular position, but it's one we feel is a responsible response, particularly because that is a Vancouver, an earthquake-prone fault line. So we are taking the conservative road. We do need to work with AREMA and others. We're working with a university in Canada, but maybe there's an opportunity to work with people here too. There's a lot of pressure on us to give up the ground acceleration as our criteria, but I do think it is the right way to go. It was in place before I got there, but I do think it's right. Didn't mention it, but we also have a lot of snow sheds and rock sheds out there on the system that are structural and in my purview for maintenance and inspection. Not always in nice areas to get to and look at, a little heart stopping sometimes, but it's all in a day's work. So then just to demonstrate some of our design and construction teams projects, we've got Gillespie. This went in service last year. I find that the double track projects that are left to be built are the hard ones. They built all the easy ones already. So we're left with the tough ones. It's usually access, the volume of traffic on the adjacent track, or to get work windows to work, the conditions of the job, always quite challenging, but always rewarding when we get them built. Twin Harbors, this is up in Minnesota. We run ore docks in Minnesota. We have a transportation company that runs steel pellets back and forth. We rerouted operations here. This was a great project for the team. They really enjoyed it because we created a loop track to reduce the number of cars needed to service this facility. It was just a winner all around, economically, fun to build, really a nice project. And Sutton to Spalding, this is just northwest of Chicago. This is a result of when we purchased the EJ&E Railroad, one of our expansion projects. This is double track, put in service December 23rd. We had a commitment to have it serviced last year. Made it by a week. Feel pretty good about that. So that's nice. And then this is my public works team, and I don't know what happened to the rest of the pictures. Certainly didn't save it appropriately, but right there at the bottom is the Fraser River Bridge in Vancouver. It's a swing bridge. It is a critical piece of infrastructure for one of our heaviest routes, getting goods and service down to the Port of Vancouver. Seagoing traffic also goes through here, so it's always a fight who gets to travel, the boats or the train. The boats have seniority. My transportation department doesn't always agree. The municipality here, or the region, is building a new bridge, the Patula Bridge. They're building this cable stayed bridge in the footprint of the Fraser River Bridge. So we're tripping over each other all the time. My public works team had to coordinate all that construction. They also impacted our bridge because they've changed the flow patterns. We were having scour at one of our piers, so we've had to work through that as well. So, but the public works team gets to be engaged in some of these. I had some really great photos. I don't know what happened to them. I apologize. So now we're gonna get to the fun stuff. So as I said, I was supposed to be here 3 weeks ago, and I was not able to join you. So just to give you a sense of where in the world, we had a bridge fire on the Grand Cache sub that's up in Western Alberta. So the star is just kind of giving you a sense of where we are with each of these events. So about 2 o'clock on Saturday, the 19th of April, I got a call that we had a bridge on fire in Western Alberta. No wildfires, so this was not an expected call. We are investigating for arson, but the 7 spans of timber approach to a steel main span burned completely. So we mobilized people Saturday. This was 3.5 hours out of Edmonton to get to the bridge site, so not an easy trip. Trying to mobilize people on a Saturday afternoon. I will say we do a pretty phenomenal job. So we had to cut in a road to get down there to start clearing debris, and what happened here is the train was approaching this bridge and saw smoke and then stopped. Very wise. So that's how we found out there was a bridge fire. So I came out to the job. I didn't get there till Friday night, the 25th. On Saturday, this is the first picture, shows you what it looks like. So within 5 days, we had a fair number of piles driven already and had started welding bracing. Day 6 there, or day 7, we started setting caps. By the 28th, we were setting superstructure. Just to give you a sense, I mean, it's pretty amazing. In 11 days, we go from having a major gap to having a new bridge section in place and running trains again. So unfortunately, this team is well practiced in these responses. So we're pretty good at it. Rather do our regularly scheduled work, but we know how to bring it together when we have to. So while that was going on, while we have most of the resources in Alberta all focused on this, we got a call on Tuesday, the 22nd. Track inspector was out on the Yale sub in southern British Columbia. And this is what he was seeing. So he took a recording. That was from up top. So he took this bridge out of service on our busiest route. So we're pumping there at the bearings. Fortunately, had a steel team within a half hour of here. So they were able to get over to the bridge. I got down there. They recognized that one of the shims had walked out on the bearing. They did a temporary fix. We were able to return to traffic within 2 hours of the first report. Start rolling trains again, and by the end of that week, we were able to get in there and do a permanent fix. So our ability to respond is very impressive. It's a phenomenal team. Okay, we're gonna get past that. Also that day in Iowa, Chris mentioned it. We've just acquired a new railroad, the Iowa Northern Railroad. It's about 230 miles of railroad in Iowa. The pool assimilation happens in June, but we had a farmer who was doing a controlled burn that became uncontrolled, and they burned part of our substructure down. So we had to divert a bridge team over. Iowa Northern does not have bridge crews on their staff, so we took one of our Iowa teams, had them go over and post a new pile in that. So that got done within 12 hours and traffic was able to resume. Iowa Northern runs most of their trains at night, so we were able to not impact their service. So again, very responsive, quick to get it done. Also that week, up in northern British Columbia on the Bulkley sub, we have a tunnel. The tunnel's about 3,000 foot long. This tunnel is under about 150 foot of fill of earth, and we have a drainage issue. So Bridges and Structures is responsible for drainage and tunnels too. Didn't know that when I took the job, one of my tasks. So we had to get out there to help with clearing this tunnel so we could resume traffic. This is a tunnel that we have some concerns. We had been out there 2 years ago. It was noted that the walls of the tunnel were starting to come in at the base, which seems unlikely because most of the base has a concrete floor. There's about 700, 600, 700 feet of the floor that is dirt. We have all the original plans. We have all the original notes. We don't know why they didn't pour a floor in this section. But we went in and hand dug out and we put in struts to arrest movement of these walls. It's a key corridor. There's really nowhere else to run trains. So we're on the side of a mountain and we're very deep. We are monitoring this bi-weekly. We go out and get laser readings off of prisms that have been set on the walls. We have not arrested movement of the walls. We have slowed it. We have slowed it significantly. So that's good, but we still have a problem. So we are working on a permanent fix. We're probably going to have to open cut half of this tunnel, but we're in indigenous lands, and where we're going to put all the fill we have to move to cut it open is being negotiated right now. Very sensitive, but critical corridor for sand to get moved. All of our movements to Prince Rupert, which is our northern west coast terminal. And our good movement to that terminal has grown substantially. So it's a problem. But we're working towards a fix. So that happened too while we were doing the other things. And then this situation was evolving. So this is down in southern United States. Back in early April this year, the 5th and 6th, we had historic rains in southern Illinois, Kentucky, Tennessee. I don't know if anyone remembers, but flooded conditions. We were out of service for a number of days. A lot of track was underwater. This location down in Kentucky and Tennessee, we had 3 miles of track under about 30 inches of water. Prior to the water going over the rail, we were walking ahead of trains. He's walking on a bridge. This is a 3,000 foot long bridge he's on. Can't see it. He can't see it, even though it's right there. This water is that murky. In order to keep traffic flowing, we walk ahead of the bridge to make sure the track is intact, then bring the train through. Do that for every train until the water is more than 3 inches over the rail. After that point, you sit and wait. You watch the water. It got up to 30 inches deep. We were out of service for 4 days until the water receded. And then we go back to doing this. We, of course, have a boat alongside him that whole time he's working. He has a life vest on with a safety vest. Prior to running a train, after the water subsided, we run a brand track with some ballast cars as a load test, just to make sure we haven't lost any scour or any foundation footings. This is a very low flow area, very still water, so we were pretty confident. We had this situation happen in February, and then it happened in April. But all that water from this has to go somewhere. It's going to the Mississippi. So the week of April 19th, we get a call from the Corps of Engineers. They're thinking they're going to have to open the spillway. Well, we are rebuilding our spillway bridge in Baton Rouge. It's a couple miles of timber trestle, and we are slowly replacing it. So when they call, I have cranes, I have materials, I have work gangs, all in the spillway. So they're giving us a 6-day notice that we have to clear out. So now I have to suspend work, demobilize everything, get everyone in a safe manner, make sure the structure is sound, make sure the remaining timber structure is sound. They haven't opened the spillway in years, so really weren't expecting that. Turns out they didn't open the spillway, but the water you see in the spillway is just from seepage. So, you know, unexpected. but a direct result of what happened 2 weeks earlier. So again, we're rebuilding a bridge up in Alberta, but we're managing all these other instances simultaneously. And we have regular work going on in the East region, and, you know, just our routine contracts, designs, and permits happening everywhere else. Concurrently up in northern BC, there was a rain event and we lost embankment on some of our operational track. This was real easy. This was like hours. They just had to come out here and fill the holes in and tamp it up and get some riprap on it. So we're all good. But, and then every day across North America, there's a truck or a vehicle striking a bridge somewhere every day. So these are just some instances, like how did that guy get up to the above? No idea. You know, the concrete truck's always going to win. But we have some bridges, we put crash beams in front of them so that they hit that. Hopefully that wakes them up, they stop, and we don't damage the actual structure. Had a few structures pushed off bearings, we've had to reset. A lot of times we just rip open the trucks. But one of my favorites is this. This is the Oshkosh Bascule Bridge in Wisconsin. Somebody abandoned their car on the track at a crossing a ways down, and the train pushed it through the Bascule truss. No damage to the bridge, thank God. But, you know, this is just a day. It just happens. It's amazing what happens out there. But I am going to talk a little bit about climate change. So I'm going to take us back to 2023. In 2023, Canada suffered a lot of wildfires. They had fires in Quebec, which is a first for many, many years. These maps show the heat map on the left, the fire damage, danger, and then also precipitation. So simultaneous to out of control wildfires, we had unprecedented rain events happening at the same time. So
presumably not at the same places, unfortunately.
close, though, close to each other. So the yellow stars are fire and the blue stars are rain. So Quebec, I don't know, it doesn't play well here in the news, but when Quebec was burning, northern Quebec had wildfires. They were bringing people from all over the world to help fight those fires. And you know, the woods are thick. There's no stopping it. There's no way to get ahead of it. And the firefighters from other regions, I remember seeing interviews with a team from Spain who came to help fight the fire. And they're interviewing these guys and they're like, it's impossible. There's so much wood. How do you stop it? It's a good question. And then up in northern BC, we had the same thing. The fires burned all winter. They never stopped. So, and then we had unprecedented rain in Alberta and in the Maritimes out in Nova Scotia. In a 1 month period, I lost 5 bridges, 3 to fire, 2 to water. The ones that we lost, the bridges we lost to fire, is unfortunate. We had sprinkler systems. That is our first line of defense. We set up sprinklers on our wooden bridges and we soak them. What happened is these fires were burning so out of control and so hot, the local authorities would not allow us in to service pumps. So you can have pumps there, they just become another asset that gets burned. The washouts, unprecedented. It was incredible the amount of water that was coming through. If we can just figure out how to balance these things and have them cancel each other out, it would be great. But I just thought I'd share. So this is a sprinkler application. This is northern BC. We didn't lose this bridge. We lost the one next to it. But you know, we set up these sprinklers. It's pretty phenomenal. If we're at a water source, there's a river below us, we can just pump. Canada has a thing called the Emergency Railway Act. We can do what we need to do to save our railroad. But we use helicopters a lot. never had a desire or an interest in flying in a helicopter, but I get to do it a lot. And then that just, I mean, this is what happened just down the track from the one we had.
Yes. How do you guys detect the fire?
Okay, the question is how we detect the fire.
Yeah.
Well, we are in constant contact with the forest preserve and the fire chiefs in the different regions. So we're usually part of the emergency calls and in the response team. We have a member.
So it's not a sensor or something like that.
Typically, it isn't. We are exploring sensors at this time, but we need to be out there before the smoke and to get those sprinklers in place, right? So usually if we're within 5 miles of a fire, we're mobilizing sprinklers and getting them established. And it all depends on how fast that fire is moving.
Yeah.
Yes.
So in this video, why is the ballast on the bridge deck, or I was assuming it's ballast, I'm not sure if it's ballast or not. Why is it red? Is there like a fire retardant on it?
We do spray our bridges with fire retardants. It is another line of defense. We have many lines of defense, but we lose often. So we try. That's all we can do is try. So, you know, I think this is the challenge for the next generation. My challenge is how do I keep these bridges in good service at their age? I think the next challenge is how do we preserve these bridges given the changes that we're seeing? Yeah.
Is the public mitigation, like fuel reduction, actually being helpful with those type of things? Because you mentioned like firefighters, oh, there's so many wood, we really can't do much about it. But what about that kind of thing?
Well, there are, like, we try to make sure we're brush clearing around our bridges. We do, you know, we do very proactive things as best we can. In terms of the millions of acres of forest in Canada, no, there's really not a lot that can be done there. So, and then just this week, you know, I had already started this presentation, so that's why we went back in time, because that's what I was going to talk about 3 weeks ago. But just to demonstrate, you know, just this week in northern Minnesota, southern Ontario, and northern Ontario, we had this. We had 5 subdivisions out of service due to wildfires. Northern Minnesota hasn't burned since I've been with the railroads, so this is new. It was burning pretty hot. Fortunately, I didn't have any timber structures in that area. They were all steel, so I didn't have any casualties. Coincidentally, just over in the UP of Michigan, this week, major washouts of our embankment. So, you know, just a few hundred miles away from each other, we're burning heavily and we're washing out. So it's just, there's really no rhyme and reason. There's no predictability. It's really hard for us to get ahead, but we're doing our best. We are working with some companies and universities on algorithm projection of the change in water flow due to wildfires on the mountainsides. You know, do we have culverts in the areas that we think are going to get the snow runoff next year? What do we do? How do, you know, we're trying to proof some of that, see if we can get out ahead of any of this. Not always be reacting. We're very good at reacting. I'd rather be proactive. But we do have fun too. Team gets together, we could do some outings, we attend conferences. We've been the recipients. CN has the President's Award. It's an in-house award system. The Bridge and Structure team has won various awards over the past few years for our emergency responses. But the team, you know, we have barbecues on site, a lot of recognition, a lot of fun. It's a good, we have a good team. CN was the recipient of the William H. Hay Award for the Macomb Spillway reconstruction in 2021. We have made a dedicated plaque. I hope, Chris, you saw that when you came to headquarters.
I didn't, but now
Right at our entrance. This is one of the piles that was used in the construction of the Macomb Spillway. We drove it out in front of the building. We have recognition of the Hay Award as well as some history on the McCombs building. So we are very, very humbled to be with those recipients. So
I have to come back.
your next visit. And so with that, I am done and I am open to questions. Yes.
What is your right of way width through the forest there? I'm trying to figure out how far back it is.
The question is, what is the width of right of way through the forest areas? Traditionally, our right of way is 100 feet wide. We do have lots of pockets that go up to 200 feet. We seldom go below 75. So, but on average, 100 is a good number to start with.
Has there been any push by, I guess, either federal or like provincial municipalities for wildlife over undercrossings on the railroad?
The question is if we have to accommodate wildlife crossings on the railroad in remote areas. So
I guess I'm thinking like Banff area, like I know Vancouver and Alberta have been building more of those for highways. So I didn't know if there was any push for railroads or push on y'all from them.
So no, I can't say that we've had a lot of pressure to install any wildlife, but that would be a municipal or a provincial effort.
Mhm.
And we would work with them, but they would have to fund it.
I think CP might have one on the line up to Kicking Horse Pass.
They do.
That's going through a national park. They do.
I mean, we have cattle pass and stuff in some places, but we are not installing new installations at this time. Yes.
2 questions about that tunnel example. I think you had 2 back-to-back slides about issues with the same tunnel. One was more recent about drainage. However, my question is about former issue, more clearance related. So 2 questions about that. Question number 1 is I'm interested in learning more about your I think you mentioned you did some laser measurements for getting the clearance for that tunnel. So question number 1 is tunnels are GNSS denied environments, so you don't have any GPS basically service there. So my question is, what was actually the system that you used? Was it manual? Was it automated to?
Yes, it's manual. We have a survey team that goes out there every 2 weeks. And they establish the baseline and establish the prisms.
Oh,
So we
okay.
can-
And then you answered my second question, because the second question was what's the frequency between these captures? Because you mentioned that you realized that the walls of the tunnel are getting tighter. So was it a known issue? Like, did you know that, okay, we need to keep an eye on that tunnel, so let's keep.
So no, I had no history with this tunnel. I went up there for the first time in 2023 when there are some cracks in the wall and the local track team felt like they were growing. And so they brought it to our attention, and so we initiated some studies. And we were able to locate all the original construction information, and that is one thing. We have a lot of data, we just don't know where it is. So when we find it, we're really excited. We had a bridge burn up in Grand Prairie 2 years ago. And it was 1,700 feet long in the middle of nowhere. Truly, I spent 3 hours lost on lumber roads trying to find the bridge. There's no self coverage, and by the grace of God, I found my way. But turns out when they had originally built that railroad, because we were able to find those files, they had built it on fill, and they started to have a land movement. And so they dug out the fill and built a timber trestle. Well, the trestle burned out. We found the original fill. We're like, oh, it's 40 years later. Maybe the ground is a little more stable. So we filled it in. It's working really well. 2 years, we survey every 6 months, and nothing's moving. So we're pretty comfortable. And that was in their original notes, like they were going to come back and remove the bridge and put the fill back. So it was a nice solution for us. We get lucky sometimes. But we don't want to run a railroad on luck. Yes, sir.
What ratio of bridges, or what percentage of your bridges are open deck versus ballasted?
I don't have an answer for you. I would say the majority are probably still open deck.
Good.
But as we build new, valves do. Yeah.
One non-technical question and then some about the precast. Do you speak French? I noticed there was,
Very little.
yeah.
And my French crews appreciate that, because when I come out and I stretch with them in the morning, we get a crazy stretching routine going, because I know they're all just chattering amongst each other, like, oh, try this, see if she'll do this. You know? I don't know what they're saying.
But like that bridge reconstruction from the fire, you showed the precast. You mentioned building bridges in-house. I have a couple of questions related to that. Do you do your own precasting or you contract that out to
Okay,
precasters?
so the question is for our standard precast sections, if we do that in-house or contract, we contract out. And primarily out of Omaha, where we get a lot of our sections.
And then I think that one of the later projects obviously looked like precast piles, but on that reconstruction you did steel. Do you wind up encasing or?
So we do encase coming out of the ground, yes, several feet down, coming up. We found there historical problems on our steel H-piling. H-piles from the 70s, incredibly corroded to the point of failure. So we have had a program to identify which bridges had H-pile from the 70s, and we've had to go out and encase or replace in some cases. We find the encasing to be fairly pricey. And so we are going back to precast piles in some instances to see, we've lost, I guess, our in-house familiarity with driving precast piles. So this year we're going back to some installations of precast to see how we do. Because the ground line encasement has become challenging.
Thanks.
Yes.
So CN operates across 2 different countries, right? So how would the policies regarding, regulation or deregulation affect the operations or in your day-to-day life?
The question is, how do the regulations both in Canada and the US impact how we conduct our business?
Right, like for example, I know that in the US, Staggers Act was passed in 1980s. And then since then, there has been like a consistent increase in the tonnage that goes on the tracks. But before that, it was kind of plateaued, it was flatlined. So like, I don't know if that was the case in Canada as well.
So I will say this in response to the original question. We do have different rules of operation for Canada than the US. I would say 90% of our operational rules are the same, but then we do have some differences to account for regulatory requirements. And I can also say for things like ATIP cars, where we do our data collection and we use that as our inspection requirements, Canada allows that. The US still requires track inspectors to weigh in on it every day, right? So we have different requirements based on what the regulatory agencies will allow from us. I have 2 different bridge management plans. Because the requirements by each governing body are a little different. So, Canada's requiring a culvert management plan. The US is absent on that topic, thankfully. So, there's just differences. There's even for our labor relations, right? We have different labor agreements, different labor laws, different requirements. It gets hard working on a network basis. But even in the US, I have 3 different operating agreements, 3 different union agreements. So I can't bring a crew from here to work here because they're in 2 different agreements.
We have some online questions as well. And by the way, we have over 80 people who have tuned in.
Wow.
around the country. I'm guessing outside the country as well, So the first one I think you may have spoken to, but I'll ask anyway. So for the tunnel problem, did the pore pressures behind the walls change over time? And are you aware of this? And does it have anything to do with the floor closing in?
We do not actually know the root cause of the change. And that's all I can do.
And there's a couple of questions related to some of your bridge thoughts. So one of the earlier slides showed that what I think may be a point cloud with some kind of modeling of a bent, like some green pile supports and a magenta cap. I don't know if you remember where this slide is.
Going back.
I'm referring to the slide with 4 images that you talked about different groups very early. I remember those.
We're going to try to get to that slide.
The shadows. They were hiding.
That's
That one.
That one? Saw that.
Okay. So the question, can you talk more about the software you use to analyze your bridges? Is that FEA? Also, can you talk about where CN is with their point cloud journey as the world moves towards that technology?
So our ATIP cars collect LiDAR data with every trip. We have a lot of data. I don't have analysts who can manage it. So when I have a specific concern, we can make a request, but we're not in that, we're not set up for that. I don't have a staff committed to that, and it's usually a fairly long turnaround. So I will hire someone to go out and get their own LiDAR and bring that to us. We did do LiDAR off the tunnel to establish baselines. And we do that now every 6 months.
Next question is, one of the attendees noticed that one of the beams from the repair projects you showed having a small notch near the bearing pad cap interface. Is that a typical feature for CN bridges? And if so, is there a particular reason for them being designed that way?
I cannot answer that. I'll have to find the photo. If I can. I don't see it in there.
There's some other ones about bearing caps as well.
Well, I'm not. That was the only bearing cap I think I showed was.
Well,
I don't see any notches. Off the top of my head, I can't think of a reason why.
okay. Another cap question. This person noticed the concrete caps that you have look wider than some other pictures that this person has seen from various sources. Does CN have a policy of wider bent caps generally?
It will depend on the length of framing. So we do have double wides if we have a longer span framing in, so we can accommodate more piling.
Okay. Completely different question. What is your preference for grade crossing materials and construction?
We are still primarily using timber at grade crossings. At least in Canada, that's my familiarity is, we've had a major grade crossing program in Canada, and a lot of it's been timber. So if we're doing something different elsewhere, a lot of our programs in the US are shared responsibilities with municipalities, so we may be doing different things.
Okay. Does CN implement either remote sensing, weather index based, or other analytical methods to identify the hot spots of potential wildfires within the next few months along the network?
So we do, we hire a service that does that for us. But yes, we do monitor and we do try to prepare in advance. Unexact science.
It's actually from a fellow CN employee, so they can follow up. Are there pre-engineered typical structures you use to emergency repair bridges and pilings? How do you decide things given the unknown soil condition?
So we do have a library of data. And so we use that because we typically don't have the luxury of obtaining borings, doing testing. So we might prove with, we do more test piles in the installation. We do have an inventory of fans located around the system. And typically we are building new bridges. So we usually have things on order and we will borrow from Peter to pay Paul and get back in service and delay the delivery of another project if need be. Back in 2021, when we had the atmospheric rivers in southern BC, we ended up in creating a new bridge location due to the washouts and the instability of the ground. We had a capacity project that was being built in northern BC, and the span was ready for delivery to that. So we borrowed that span and we created a bridge to fit what we had available and delayed delivery of the capacity project by a year.
One more question just came in. Do you use direct fixation fasteners on any bridges or tunnels?
We do have direct fixation on a number of bridges. It is not our desire. We acquired the railroad of Minnesota. Those are all steel plate decks with direct fixation rail. Some challenges for the signal system and maintenance. So not our, but if it needs to be, it needs to be. There is questions in the back.
Yeah, I was curious. And I saw the bucket trucks using to inspect the bridges. Do you use any UAVs to be able to reduce the time on the road? Drones to be able to inspect them.
The question is if we use drones for bridge inspection. We use drones for many things. We do complement our bridge inspections with drone, if access to the top of trusses, things like that, but we don't solely rely on drones. But yes, we do complement our services with them.
Do you use any like expansion joints on bridges to be able to reduce longitudinal forces, or?
At times, yes.
Is it standard or just as needed?
It's as per required. Yes.
So I guess I have a question about, I guess I'll use the embankment and like the embankment in Champaign and like all the bridges in downtown Champaign. Like that was built for like, I guess like 3 or 4 tracks and like only 1 track is in use now. So for like that bridge maintenance and like that ongoing maintenance, is it only really focused around the 1 track in service still? Or is it like just keep the whole bridge there in case we need the other, the right of way later?
So the question is, do we maintain our active tracks versus all of our right of way?
Yeah, for like bridges with room for more tracks.
Remove tracks. Our focus is on the active railway. We do have locations where the second track, a lot of locations where the second track is maybe no longer in service, and we use the road as a maintenance. The bridge ends up being a maintenance bridge. So then we continue to inspect it. If it's truly out of service and nobody's using it for anything, we do not have it in our annual inspection program.
So Derek's question causes me to ask another one, which is that in Champaign, there are several underpasses where there's multiple spans and the track is only on one of them. If you have a bridge strike from a truck, it might well hit one of the spans. Yeah, right. Do you have to inspect those. I'm assuming you're not stopping train traffic in that case, but until it's inspected. but
We
you
would still come out.
would still inspect it, make sure it's not
Yeah.
gonna fall
I'm
down.
assuming we still own all the right of way,
Yeah,
because in some cases we don't.
okay, thank you.
And then,
Yes.
okay, I guess I have another question about culverts. Do you guys have any like program or I guess like a lot of detectors or something to, I guess, prevent like culvert blockages and maybe washouts from that, or is it just kind of a, I don't know.
So we have, the question is, how do we manage our culverts and potential blockage? So culverts are inspected regularly. And it's part of our regular maintenance is to clear them if they are blocked. So yes, we do have a program. It's part of our routine maintenance. But is it foolproof? No. There's a lot of culverts. Can't always find them all either, but we do our best. Well, thank you. That was a lot of questions.
Thank
So-